In this lesson, we are going to talk about the eccentricity. As you can see here, we have this building with the x and y dimensions. And this building has 2 points. The first point is the center of mass, and the second point is the center of rigidity. The distance between the center of mass and the center of rigidity, Ex and Uy, should be 0. But that may not be possible due to the building geometry. So that the equivalent static method requirement is that the Ex shouldn't be more than 15% of dx. Also, Ey shouldn't be more than 50% of dy. Now I need to do that check in Etabs. So go to the Model Explorer window, then expand the Table Windows branch, then Analysis branch, then Results branch, then Structure Results branch. Now click on Center of Mass and Rigidity. As a result of that, a new table has opened up. This table contains the stories, diaphragm, total mass in the x direction and in the y direction, the center of mass in the x and in the y direction, the cumulative masses in the x direction and in the y direction, the cumulative center of mass in the x and in the y direction. And the final columns are the center of rigidity in the x direction and in the y direction. Now I need to check if the Ex is more than 15% of the dx in each story. So I am going to use an Excel sheet for that. First, select all these values. Then right click and choose copy. Then in the eccentricity Excel sheet, right click and choose paste special. Here in this form, select text, then click OK. Next, under the dimension column, set the dx and the dy of our project, which was 21.5 for the dx and 25.8 for the dy. As a result of that, the Excel has calculated the Ex by dx percentage, and as you can see, it's less than 15% in all stories. Also, the Ey by dy percentage is less than 15% in all stories. Finally, I need you to notice that if the eccentricity is more than 15%, that means you need to solve the problem. And the best way to do that by making some changes to the shear walls. For example, you can increase the thickness of some shear walls, or you can add a new shear walls. Also, you can redistribute them. The point is to make the distance between the center of mass and the center of rigidity is minimized as possible. Now it is the end of our lesson. In the next lesson we are going to talk about the irregularities types. So hang on for that.